We have patterned these seasonal workshops and meetings hosted by One Health Group Alaska. Okay, did everybody see that slide change? I just want to make sure my computer's been acting really weird lately. Okay, so the One Health Group Alaska, it's a 10-year-old forum to raise awareness about emerging One Health issues. For those who may not have heard of One Health, it's an approach to public health that recognizes the interdependence among humans, animals, plants, and the environment, something that Indigenous people have been doing forever. So Alaska and the northern latitudes more generally, there have been experiencing significant change, largely due to the loss of sea ice and permafrost and thermal barriers in general. Their ecosystems are reorganizing into something new with serious implications for seafood safety, food security, public health, tribal culture, local economies, and on it goes, right? So this group convenes to share things they've seen, things that seem out of place, out of time, and to share what they've learned every quarter. So you may know that WATCH has a special focus on harmful algal blooms, or HABs, what some people call red tides. One Health Group Alaska has recorded several HAB-related presentations if you're interested. These are just the ones with HABs in the description, so there's likely to be others as well. And if you notice the URL on the site, it includes the LEO network, which I'll talk about in a moment. We hosted a design workshop in July with some of you to see how we might tailor these workshops to better meet your needs. But this is our first official seasonal workshop. The July event included some excellent presentations from our own Jordan Brubaker, who you'll hear from in a moment, from Nick Chowdhury of Island Marine Aquatic Working Group, IMOG, a valued WATCH partner, and from researchers Jana Whale and Emily Spencer. So thanks to everybody who contributed to that event and through your participation there or the feedback survey. And I'll put the link to today's feedback survey in the chat a little bit later. We appreciate you helping us to shape these workshops, and we want them to be as useful as they can possibly be. So you might recognize Wildside Trail on Flores Island, a little rough, but you find delights around every corner. That's what we hope to be. And each seasonal workshop will include an update on the WATCH project, a review of seasonal weather and climate conditions, and observations of unusual events provided by you or harvested from media, what we call looking back, looking forward, presentations on timely, irrelevant, or hot topics. And today we're very excited to hear from UBC's infamous now, Chris Harley. Then we want to hear your updates and observations of unusual events. And then each seasonal workshop will include an opportunity to discuss what we're sharing and how we might use this information to address or flow with the changes that are happening. So with respect to your updates, you're welcome and encouraged to share new papers or reports or upcoming events in the chat. But the emphasis of these seasonal workshops is to routinely share recent knowledge and perspectives from and to and from communities and organizations doing work in ocean climate health, coastal health, marine food safety and security, and other related spaces, so that we can all learn to recognize and address or adapt to the changes we're experiencing or anticipate in the near future. We plan to record these workshops. We're doing that now, and either summarize or make them directly available on the WATCH webpage. If anybody wants to learn more about submitting observations, unusual observations, after Sequoia closes for us today, I can show you a brief video prepared by the FNHA's LEO network. That's Local Environmental Observer Network, also patterned on LEO Alaska. Hi, Dion, so nice to see you here. And I will provide the links to the One Health webinars and LEO Alaska in the chat also for anyone who's interested. And one last thing, a disclaimer, neither Jordan and I are climatologists, so we may be limited in our ability to respond to some of your questions. If anybody in the room can answer some of these, please speak up. However, if you have questions we can't answer today, we're really great at tracking down knowledgeable people and answers. Since this is our first update, I'll include important events from the spring, but in future, these will be limited to the preceding season. So this spring, we onboarded 4 new monitoring communities: Snuneymuxw, Tumminus, Tla'amin, and Sayout First Nations. There was a this is a follow-up from our fall events where we had the awesome privilege of learning from our US partners. Some of them are in the room today and they are truly awesome. Worth noting is Tina Wesley sitting here at her computer. She's the former Watch Lee for Klahoose, one of our pilot communities. She kickstarted this initiative at Saniwan. For that, we're very grateful. Thank you, Tina. Community staff, guardians, fisheries, marine department staff, they're outfitted with microscopes and phytoplankton nets and all kinds of exciting stuff and trained to collect samples and identify the big 3 toxic phytoplankton. And that is Alexandrium, Pseudonychia, down here, Dinophysis, what some people call evil hamburgers, evil kayaks, and evil Kool-Aid men, whose toxins can lead to paralytic shellfish poisoning, PSP, amnesic shellfish poisoning, ASP, and diuretic shellfish poisoning, DSP, respectively. So these communities are already moving the needle of HABs, HAB alert systems, risk communication for us. And we were also pleased to welcome back staff from our pilot communities, Malahat and Shot, and get to know their new staff. Our training sessions were held at Vancouver Island's beautiful Deep Bay Marine Field Station, a wonderful partnership for us. And hi, Maureen, it's nice to see you. But a little far away for routine visits from our northern and central coast communities. So a future watch program, which we will need after our pilot ends in March, will hopefully have similar sessions, training sessions on the central and north coast, or a big budget to bring them here. So some of you may have seen this recent article, and I'll put a link in the chat. In a single story, it kind of brings to light many of the reasons that we're doing this work. So in June, our phytoplankton specialist, Jay Pedota, he met the Tla'amin Guardians for their first field training day. And when they reached the beach to collect the phytoplankton sample, they found all these people harvesting, more than 30 people, mostly recreational harvesters. And one person was shucking oysters and popping them into his mouth. And so when they looked under this sample that they collected under the microscope, they found very high levels of Alexandrium, phytoplankton that produces saxitoxins that can lead to paralytic shellfish poisoning. You can see if you see the skull and crossbone signs in the beaches, that's the one that DFO is warning you about, the really serious shellfish poisoning. And so the Guardians informed some federal agencies, warned the community, talked to the harvesters about the risks. And it wasn't for 11 days. 11 days later, DFO closed the beach. And the CFIA conducts weekly biotoxin tests somewhere in the area. We don't know where the sample sites are. They're not necessarily aligned with these phytoplankton sampling sites, which we hope to change. And they take a week to report results in many cases. So they found the shellfish contained 16 micrograms of saxitoxin per 100 grams of tissue. The action level is 80. If the level exceeds 1,000, Washington State calls it a lethal level. So we discovered that a girl had been hospitalized with suspected paralytic shellfish poisoning from eating spot prawns in that area, but I don't know much more than that. I wish I could tell you a little more. At this point, I just don't know. Canada has no testing for prawns and crabs. So WATCH is recommending that people devein prawns and clean crabs before cooking, as toxin in the digestive tract can be transferred to the meat by cooking whole or even transformed into something more toxic than it was before. When these critters are in the water, it's best to be safe. So last week, the Washington Department of Health let us know that they were experiencing a lot of PSP activity in nearby Puget Sound. And I just got a notice this morning that there's similar stuff going on in the outer coast as well. Sound toxins, and welcome, Michelle. So happy to see you here today. The Puget Sound Phytoplankton Monitoring Program was reporting high levels of Alexandrium mussels at one site. They tested just under 5,000 micrograms of PSP toxin, and there were lethal levels at several other sampling sites. So they attribute this to rains. After a long, hot, dry summer, the rain just doesn't soak into the ground. It flashes off with all the nutrients that have been locked up, and it fertilizes the phytoplankton. So with the Washington State symptom system, tongue-tied, sorry guys, of combined phytoplankton and biotoxin testing, usually sampled by the same person at the same site, they know the bloom season is generally starting earlier in the year and ending later. That every year there are new closures in places where they hadn't been before, that new toxic and otherwise harmful species are showing up in their waters and likely in our waters as the climate changes, and these phytoplankton monitoring programs are picking them up. And otherwise that they might not be knowing about them. And that late season blooms are problematic. As the water gets colder, shellfish metabolism slows down and they hold on to that last toxic meal. So it's important to have the testing in place. So Watch is interested in facilitating more phytoplankton monitoring, more rapid testing of toxins, similar to the COVID tests, presence, absence, where the technology exists for ASP and DSP toxins potentially, and also more lab capacity. And nice to see so many people in the room that are helping us work in that direction. We are super grateful for that. So another gem they shared with us is Washington State's Pseudonychia Early Warning Project. And I thought this is a really important thing to tell you about as well. So Pseudonychia is the phytoplankton that produces the toxin domoic acid and amnesic shellfish poisoning in spring and summer of 2015. You may remember something called the blob. It was a large Pseudonychia bloom associated with a huge marine heat wave. There was anomalous warming at that time, up to 3 degrees warmer than normal, and an El Nino, one of the strongest on record. The bloom caused widespread and long-lasting harvest area closures of razor clams and crabs, toxin advisories, and plankton-eating fishes like anchovies and sardines. It was linked to seizures and deaths of marine mammals and birds. The marine heat wave also delivered smaller, less nutritious warm water plankton, as well as warm water fishes to our waters. Some salmon populations declined. It harmed kelp and eelgrass. And if I recall correctly, and maybe Chris can confirm this later, is I think this is when we first started to see sea star wasting disease. So Washington State wants to know if Pseudonychia is offshore and producing domoic acid. They have offshore winds that cause upwelling, which fertilizes the water with nutrients. And if there's a front, this brings the Pseudonychia onshore, essentially concentrating those phytoplankton in areas where there was recent upwelling, and then conditions are right for a bloom. So they have a mooring buoy, an environmental processing center collecting data all the time. Pseudonychia cells, according to this, that what I saw last night, are less concentrated than they were a month ago, but they're still out there. They're also in the process of employing an AUV, I think that stands for Autonomous Underwater Vehicle, at HABS hotspots that can bring that water home to coastal labs for analysis. And I just got a notice this morning I mentioned, and it sounds like they do have quite a bit of Pseudonychia and domoic acid on that outer coast right now. So after the last seasonal reflections workshop, I presented a seasonal rounds exercise for Dungeness crab. And the reason I'm bringing this up is because I'm looking for people who might want to work on species backgrounders with me to better understand climate-related exposure sensitivities and adaptive capacities of important marine food species. So please reach out if you're interested. And this is our calendar. So in October, our monitors, HAB specialists, and some others are meeting at Deep Bay to better understand the risks of HABs, how to communicate risk. VIU will be telling us more about their projects with the CFIA to increase shucking for biotoxin testing, trial rapid tests for domoic acid in shellfish, and assess paralytic shellfish toxins in urchin. VIU Chemistry will be introducing rapid tests for cyanobacteria, which some refer to as cyanoHABs in freshwater and estuaries. And like constructing a puzzle, we're trying to put together an alert system that better serves First Nations. In December, we'll be holding the next seasonal reflections workshop, looking back on the fall, looking forward to winter. We have another fabulous presenter joining us, Kathy LeFay from NOAA in Washington, who's helping us understand how toxins are distributed in the food web and accumulate in marine mammals. It could be more than that, but that's what I know right now. So we will be sending exit surveys to hear more about you from you for the end of the pilot project. And that'll happen in the new year. And for those who are keen to do something about sanitary and chemical contaminants of concern in seafood, Vibrio and norovirus, for example, we plan to host a contaminants of concern event in the new year. Somewhere in there, we'll be writing a major report that we hope will be a solid resource for coastal communities. And the spring workshop will be in early March.
I'm calling in today from North Vancouver Island on traditional territory of the Comox First Nation, among a few others, actually. And you should be looking at a beautiful photograph now of the coast, of BC's coast. And the seasonal reflections piece that I've kind of come to take on is related to kind of this looking back at the past season. We'll look at the weather events that occurred and put it in context of news articles, actually, of observations that people have been making and reporting, and to try to kind of make sense of what happened in the more recent past, and then how we got to where we are today, and then kind of turn to some forecasting data sets to see where we're kind of heading, where we might be heading over the next 1 to 3 months. And yeah, one of the reasons we like to kind of take this approach is because climate change is so often spoken of in these really long time frames, 2100 and these years that are so far out. It can be hard to kind of relate to, and so we're hoping that these kind of shorter time frames can kind of help ground the conversation of climate change into a time period that we all live and work and kind of make decisions in, and hopefully this can kind of help guide us as we kind of just move through the seasons. Let's see here. I can change my slide now. All right, so we're looking at last year's 2022's drought classification chart and these are just actually the coastal BC basins. So we've kind of just simplified it a little bit so we can just kind of focus on the coast. And you'll see there's 5 levels of drought classification, and the 0, the blue color there, meaning that there's lots of water for all of the socioeconomic and ecosystem needs. And then, values 1 through 3 are sort of like indicating that there could be, some possibility for some adverse impacts. And then, the orange and the red we've highlighted so that it's easy to see these cases, because this is where these adverse impacts are likely and almost certain. And you can see that these last year actually was just flush with water right into the middle of the summer. And it wasn't until, the end of September, we started to see some drought kind of really start to take hold in the kind of central coast and south coast. And then in October, it just kind of became a full-blown drought emergency in a lot of these same regions. And it actually carried through right into November. These are usually very rainy months, usually a lot of water returning into the streams for salmon to spawn. And this caused all sorts of issues with spawning salmon around that time. And the reason why we're kind of casting all the way back into last year is just because this drought that surfaced last fall is largely still has carried through until the present day in one form or another, which is quite a shocking development. And so we'll kind of start here, and we'll end up we'll carry on through to the spring of this year. And so the way we kind of talk about weather, I guess, in these presentations is we talk about anomalies. And in this case, I've spelled the word wrong in some of these earlier maps, so my apologies. But the idea of an anomaly is basically that we've subtracted the observed temperature in this case for this spring, and we've subtracted that from the average temperature of an average spring, and then you're going to get a difference of how was this spring relative to a quote normal spring that you would expect to see. And so that's why the values look the way they do. So anything above 1 being it was hot, anything below, or sorry, below, above 0 would be hot, and below 0 would be cool. And the colors showing that information as well. So you can see that the spring, it was actually kind of divided. The north part of the coast was central and north coast was a bit of a cooler spring. And then the south, central kind of south was a warmer spring, with the exception of the west coast of Vancouver Island that actually was a little bit cooler than normal. However, these 3-month averages don't tell the entire story. And so it does lose a bit of information that happens month to month. And so that's why we started adding these monthly plots that I've just showed on the left-hand side here. And this is actually the exact same data. Every single dot in that chart is a weather station that you can see on the map. However, now we're able to see what those values were for each month and how they progress throughout the season. And so if the value is below that red line, you can see that that was, in this case, a cool month or a cool measurement at that station. And then if it's above the line, it was a warm measurement. And if it was directly on the line, that would be just a run-of-the-mill, typical average measurement. And so you can see that from March and April was actually cool. Those 2 months for every station, almost every weather station was cool. And then May, it just completely reversed, and every single station measured a very warm reading. And that has largely just continued to this day, that trend. And so another little tidbit is those colors of the dots actually represent how far up and down the coast those are, in case you're curious of which weather stations contributed to those values. You can kind of get an indication as to which, if they were towards the 49th parallel, for example, in Victoria, or way up north, and those yellow those yellow dots would be up near, Haida Gwaii. So during the same time period in the spring, it was dry. It was dry, and this was the pattern that had carried through the winter. It was a drier winter than was to be expected, and then carried straight on through to the spring. And by and large, it was the Central Coast that kind of measured those really strong moisture deficits, and as well as a few regions on the west coast of Vancouver Island. Down by Cowichan Lake, you can see they're also lacking a lot of rain this spring. And not one weather station measuring a surplus over the course of this three-month average. Looking at month to month, it does tell a bit of a different story. You can see that actually the month of April was a wet month. There was quite a bit of moisture there in most stations, but the deficit from March and May just dragged that average down to contribute to this overall just really dry spring. Around the first week of April, unfortunately, there was some really surprising discoveries of some dry systems. Fraser River had its lowest water level in over a century, and a bunch of other lakes kind of tied to that system as well had really low water levels. And this was, in large part tied to that drought from last fall, lingering through the winter, and that just came straight on into the spring. Typically, the snow melts that's associated with this kind of spring flush of water known as the spring freshet, is sort of dragged on a little bit into the spring and is caused by that gradual warming of the snow, and it slowly melts and trickles into the rivers. But because of that really hot May we saw, it actually wiped out that snow much quicker than usual. And so by April, that snow was largely gone and contributing to these really dry systems that unfortunately resulted in a number of salmon eggs being dewatered and likely being killed. It was this surprising discovery as well, where the global oceans were warming in the beginning of April, before the El Nino actually surfaced. And the El Nino was sort of expected this year, the El Nino being that kind of oscillating between warm and cold of the equatorial Pacific region that kind of drives the climate of the whole kind of western side of Canada. And that ocean warming hadn't really started yet in the equatorial region, but the rest of the ocean was actually warming kind of before that. And that was sort of a really surprising development. And people were really taking note of that. So as we moved into the summer, which we're defining as June through August, the temperatures were continuing on their trend of being very warm. Mostly, the Central Coast and the east side of Vancouver Island were, the warmest, but everywhere was measuring warm temperatures. And if you look at the, excuse me, the month-to-month values, you can see that just every month was warm. There wasn't really like a break in that trend. Looking at the precipitation, it was a little bit less homogeneous. You can see the west side of Vancouver Island really had suffered more of a deficit of rain, and as well as the Central Coast had a really extreme value there. Whereas the east side of Vancouver Island fared a little better. And yeah, looking at the month-to-month values, you can see again that almost every dot fell below that red line, suggesting it was just pretty much dry across the board with a few exceptions. So yeah, by the beginning of summer, people were already starting to see the writing on the walls, unfortunately, about what this might mean for wildfire. And so this BC Wildfire Services quote, they mentioned this classic saying that the intensity of the fire season will greatly depend on the amount of rain received in June. And here was that June anomaly map chart that we just showed, and nearly every single station lacking in rain. So just kind of backing up those observations there.
Yes, I'd be happy to talk to them. Thank you.
By June 8th, it was official that the El Nino did actually appear, or was defined as starting, and that's that big red band you see around the equator there. That's just a classic El Nino warm pattern along the equatorial region of the world. However, all that other red that you're seeing and all the other kind of oceans of the world, that is really not the El Nino, and that's contributing, or that is sort of this surprisingly global warming of the oceans that's sort of being talked about throughout this presentation. By June 15th, the River Forecast Center for the Government of BC put out their final snow water index report, and they were showing that the snowpack, the seasonal snowpack, not the glaciers, but the seasonal snowpack was just at 4% of the normal at this time of the year. So it was, by and large, the snow was gone. And again, related to this, lack of snow for one thing over the winter, not a ton of snow, but also that really warm start in the spring in May that would have melted a lot of the snow. And so this is why the River Forecast Center had suggested, high risk of province-wide drought because of this lingering effects of fall drought. They're usually dry, rapid snow melt, and then the likelihood of above normal temperatures this summer, tied to that El Nino. While it is, a very frightening kind of report, there was actually some good news stories that I did come across. This was, one of them. There was actually a good or a smooth sockeye season in the Somas River up by Port Alberni. So even though they were kind of navigating these really kind of warm months, there was this little window of break that they got, and they actually did get a number of sockeye running up that river. So that was a bit of a good news story we wanted to share as well. By July 3rd, the global temperature record was broken, and you can see this chart just shows the current year in that dark black line compared to the last few centuries worth of lines, and you can see that it was just kind of way out and continues to be way out of that normal range. A sad discovery was made on the second week of July in the Cowichan River. Some swimmers discovered some dead salmon fry, I guess, the 2-year-old salmon fry that were 7 centimeters long. And this was kind of in a region kind of halfway up the river, and people had guessed as to why this might be the case, but no one really had a definitive answer. This story is developing still, and there'll be an article that I'll share a little bit later of a more recent update. By mid-July, the forecast of a big wildfire season was pretty clear. As of July 12th, there was 30 times worse wildfire season in BC than average. So obviously the wildfire is continuing the season, and so I'm not sure what it's at this point in time, but obviously a very exceptional year in terms of wildfires. So not only was July 3rd the first kind of record-breaking day, by the time the month of July was over, it was the hottest month by a long shot, as quoted by NASA. And then not only was the temperature, the air temperature the warmest, but the ocean temperature too recorded the warmest month on record. So just across the board, a really record-breaking kind of a summer, and sort of just highlighting that we're in uncharted territory. By August 5th, 80% of the basins in BC were considered to be in extreme kind of levels of drought. And then by August the 10th, this marine heat wave that we had been monitoring at our last season of reflections, this 4 million square kilometer kind of warm mass of water that was kind of hanging out well offshore in the middle of the Pacific when we met last, has quickly reached our shores, unfortunately. And so looking at the global sea surface temperatures, you can see in a similar kind of line chart here, comparing all of the sea surface temperatures going back to the 80s, that currently the global oceans are far outside their normal range. Unfortunately, unlike the sockeye of the Somas River, the sockeye season this year in the Fraser River has been just awful. And this is actually surprising, well, maybe not surprising, but it's not really related so much to the climate this year. It's actually related to this big bar slide that occurred 4 years ago on the Fraser River. That was, if you recall, it was a bit of a landslide that choked off a large part of the river and caused a massive kind of waterfall to form that the salmon just couldn't make it up. And so while that isn't really necessarily tied to climate change, though, you know, extreme weather events can cause those types of events to occur more frequently, we did want to mention it, and also just to mention that these types of, you know, ecological impacts can have these big lag periods. You know, the salmon returning this year, you know, can be tied to these events 4 years ago, for example. Just a few weeks ago, 3 different rivers on the South Vancouver Island have now been placed under water restrictions for various industrial purposes, such as watering for forage crops. And this is, you know, to protect those salmon that are hoping to make it up those streams to spawn, and that are probably trying right now to make it up those streams. And people are actually calling to close the Cowichan River to fishing. And this is an extension of that story, that discovery in July that swimmer made of those dead fish after, I guess, doing a lot more investigating, they confirmed, or I guess it's developed into a 6.5 kilometer long dead zone of the river now, where actually there's no fish at all, and a lot of dead fish, many of which have been picked off by foragers by now. So they're not clear exactly how many there were that died, but and they're attributing this to low dissolved oxygen, high pH, related to algae growth, and then high temperatures and low flow. And unfortunately now, this is just an update from yesterday or the day before. The Cowichan River is at its slowest flow, and the drought continues to intensify. And now they're actually being forced to pump water into the river from the lake, essentially just putting the river on life support, because without that pumping of water into the river, it would actually just run out of water. So some individuals, such as this biologist, Jim Lane, was wondering, what will the impact be of 2 consecutive years of drought on these salmon runs? And just highlighting that we're, again, in uncharted territory, don't have a lot of experience to draw from in this unique year we're in. This recent article as well, just highlighting that, while we're talking about drought, we actually also should be thinking about floods, because, just like, when you forget to water your house plant, and then you get around to watering it, and all the water just kind of rolls off the top and runs onto the floor. That's basically what can happen if you have a really big rain after a really long dry period. The ground just can't absorb it, and so it can cause these big floods. And then on top of that, when forest fires come to be, they can actually cause the soil to be even more repellent to water. So hopefully the ideal situation would get a little bit of rain, kind of prolonged moderate rain that can just kind of gradually rehydrate the soils. So bringing us to the current day, the current drought level classification. This is last year's, and they don't really record it over the winter, or at least they don't release that data for some reason. And then building on where we are this year, you can see that we're heading into September, and we're across the board, it's a drought again. However, if you look at last year, there wasn't even a single 4 or 5 rating at this point yet. So it's a little scary to kind of just see where we are relative to last year. But looking at where we're heading, we can look at the El Nino index, and you can see we're well into this El Nino now. NOAA is suggesting that it's a 90% chance it will continue through the winter and likely strengthen. So highlighting this likelihood of this trend, continuing at least over the next little while. Environment Canada puts out their 1 to 3 month forecast. So September, October, November, October. It's covered up by the screen here, September, October, November. And you can see that they're forecasting a high probability of a kind of a moderate amount of warming over the next few months. And with the higher probabilities being in the south side of the coast, 80 to 90%, for example, down in Victoria area, and then up to down to about a 60 to 70% chance up near Haida Gwaii of this 0.5 to 1 degree Celsius hotter fall. And then as for water, as for precipitation, it's a little bit better of a story. There's really not much of a signal in their models for most of the province. However, for Vancouver Island and the Lower Mainland, they're giving about a 40 to 50% chance of a slightly drier fall, which is about equal to a coin toss. The Agriculture and Agri-Food Canada puts out a drought outlook, and they just released this yesterday for the next month. This is the 1 month outlook, and they are anticipating that the drought is going to remove in this large green blob that you see. It's going to improve in the yellow areas, and then no change in the brown, and then with it getting worse, unfortunately, in the sort of Gulf Islands and southern mainland region. And then just one more forecast. This is for the sea surface temperature, for the global sea surface temperature. Unfortunately, we don't have a great zoomed in version to look at our coast specifically. Obviously, it's just a sea of red indicating high probability of warming over the next few months globally and of the sea surface temperature. I suppose one good news piece is if you really look and squint at our coast in BC, you can see there's actually a little bit of white kind of along the shore. So maybe this forecast is a bit offshore, but perhaps Chris Harley can enlighten us as to the likelihood of that or not. So these are the data sets that we used. I'm happy to share any of these resources with any of you all. And yeah, sorry it was so fast, but there's just so much to cover. And there's just so many news articles. We can only share so much per event here, but thanks everyone for your attention and really appreciate it. I think we can take some questions if anyone has any questions. But if not, we can just kind of roll into the next section of our agenda.
Does anybody have any questions for Jordan? There was a question in the chat, Jordan, but Chris has already answered it, which is great.
Oh, super.
Actually, I just to clarify, Jordan, I didn't quite catch what you said in terms of which, whether it was averages from the previous 30 years that you were comparing the anomalies to, or the temperatures from the spring. If you can just clarify that exactly, that'd be awesome. Thank you.
Thanks. Yeah, I have it written down. I believe it's from the 90s till the early 2000s. It's actually very recent, and it's not like pre-industrial eras. And I guess the reason why that is, it does seem a little bit misleading to do that because you're kind of ignoring all of the warming that's already happened since, you know, the Industrial Revolution. But I guess it gives you a bit more of a sight as to where we're heading in the shorter term if you do these more short-term comparisons.
Okay, thanks.
Thanks. Great question. Thanks.
What I'm going to focus on today is the big heat dome we had in Western North America back in the summer of 2021. And my alternate title for this talk is, well, that stunk, because of the horrible smell that was wafting off of many shorelines in British Columbia and Washington from all of the marine life that had died. And when we think about sort of climate change, and Jordan has already alluded to this, it's often by the year 2100 something, you know, may happen. And I've done research at those sorts of timescales, but I'm also increasingly interested in these much more immediate impacts of big events. And there's a quote that I really love, which is, "Climate trains the boxer, but weather throws the punches." The ecosystems, the shellfish are responding to the punches, and you know, we see that with the salmon and drought examples that Jordan outlined. So my question is, how will coastal marine ecosystems respond to these big heat waves, which are going to unfortunately become more common and more severe? And there are marine heat waves also, which are sea surface temperatures. And this figure I downloaded yesterday. So this represents sort of the last week in the North Pacific. And as with Jordan's anomaly plots, this shows a big stretch of ocean that's about 3 degrees warmer than you know, what would recently be considered normal. And at least right now, that's not pushed up against the BC coast. You can see that little strip of cool water along the west coast of Vancouver Island and up towards Prince Rupert. But you know, we'll see what happens in the coming months. Often with El Niños, this warm water sloshes right up against the shore, and that's when we start seeing, you know, really unusually warm waters. And we've already had a little bit of a taste of that last month. Okay, But for the systems that I do a lot of my work in, that's the things that live between the high tide line and the low tide line. And so half the time they're underwater and have to deal with, what's in this photograph. And the other half of the time they're out of the water and have to deal with atmospheric heat waves. So the big 2021 event was an atmospheric heat wave. And the scale bar for the anomaly on the right now doesn't just go up to +3 degrees, it goes up to +20 something degrees. That heat dome in 2021 was something that had been almost inconceivable to meteorologists. They were really not expecting to hit temperatures that high this soon. And the poor town of Lytton there, indicated with a star, broke the all-time Canadian temperature record on, I think it was on a Saturday, and then they broke it again on Sunday, and then they broke it again on Monday, and then burned down on Tuesday, and 2 people died in the fire, and over 600 people died in the province. So this was, really catastrophic. But it didn't just affect people; it affected a lot of wildlife. Now, if you happen to be on the shore on the hottest day, which a student and I were, this is in Lighthouse Park in West Vancouver at low tide, and sort of the bummer, if you were something like a mussel, all this black area here is mussel bed, is that not only was it exceptionally hot, the tides were also very low, and the low tides were right in the middle of the afternoon, which was the hottest time of day. And the student and I were actually concerned about our own health and safety, because it was like being in an oven out on the rocks that day. And it's difficult to appreciate that with this photo, because this, if you just showed this to me, I'd say, looks normal. But we did take an infrared camera with us that shows the temperature. So the number on the upper left is just where the little bullseye in the middle of the image is. So the water was reasonably warm. The scale bar on the right is what I want you to pay attention to. So some of these rocks are up into the 50s, and parts of the mussel bed were in the mid 50s. And I've seen temperatures that high in places like Hong Kong, but I've never expected to see that in Vancouver. So that was exceptional. And if you're curious, that's well above the temperature that our local marine species can survive. And if you're paying close attention to this photo, you can even see the mussels are gaping open here because they've already died. All right, so what were some of the consequences of things getting that hot? Well, a lot of things did not survive. So we found some starfish that had died, and some crabs that had died, and some of these dog whelks that had died, and a lot of, cockles and butter clams died. But for, maybe excluding the clams, most of the rest of the animals in this image are mobile. So they sort of get a day of warmer weather, and then they're no dummies. They go and find themselves a nice, cool place to hide. So for these things that can move around, it wasn't that catastrophic. Yes, a few individuals got caught out in bad places and didn't make it, but those populations mostly did okay. If, however, you were directly attached to the rock and had no place to walk to, or crawl to, or swim to, then you were really in trouble. So we saw a lot of seaweeds die. The mussels in the middle, you can see those are gaping open with the meat still inside. That looks like, what you would be served in a restaurant, that has been cooked. And the barnacles on the right died. And, normally when there's some sort of big ecological event, the scientist in me gets very, very excited, and I go out and collect a bunch of data and nerding out on it. This event was one of only probably 2 things in my career that really strongly impacted me emotionally, the other being sea star wasting. Because each beach I went to, there was just this sense of fear of what you would find, because you would, park the car and you could already sort of smell the mortality. And be grateful that I can't share the smell with you, but I'm going to try to share the experience, and hopefully the sound will come through. This is walking across a mussel bed on Galiano Island in the southern Gulf Islands. It doesn't normally crunch like that when you walk across it. Live mussels hold their shells together and can support your weight, but these are all empty shells, and you can see this mussel bed just goes and goes down the shore. So this was a spot where, you know, that little patch of mussel bed was only about the size of a tennis court, and we estimated that there were about 1 million dead mussels there that had died during the heat wave. So if you start multiplying that up and adding things in like barnacles and other species, that's how we're estimating that at least, say, 10 billion animals died in British Columbia alone. There were some patterns to where this happened. So on the left, we have air temperatures. On the right, sea surface temperatures. You can see the Strait of Georgia is just naturally a warmer body of water than the Strait of Juan de Fuca. But focus on the air temperatures, and these temperatures that are up in the 30s and 40s, very unusual for this region. So the Strait of Georgia was very vulnerable to this. Up on the central coast, it wasn't so bad. And when we went out and just measured the mortality of several species of barnacles and oysters and mussels and dog whelks and other things, you can just see by how darkly filled in these pies are that, the more black you see, the worse this was. So these areas in the southern Strait of Georgia got hit really hard with mortality over 50% at a lot of these sites. Victoria area was a little bit more hit or miss because it was a little bit cooler. And then once you were out past Souk or out towards Bamfield, the mortality wasn't that bad. And the same for up on the central coast around Calvert Island. There was one beach that was hit pretty hard, but most of these places were okay. So at these big scales, there were areas that were more vulnerable and areas that were less vulnerable. But that was also true on really small scales. So in that wonderful opening we got from Sequela, who was standing at the Vancouver Convention Center with Stanley Park in the background, the data I'm about to show are from Stanley Park. And although the photograph from the left is not, it at least gives you the sense that shorelines are complex. And there's some south-facing areas that you think might get really hot and some north-facing areas that might remain in the shade. So this graph is plotting that. So over on the left, this is sunlight coming just directly down onto the surface, the most solar energy possible. And then as you sort of, move around a corner or over a little ridge, you get to sort of shadier and shadier areas until you hit the edge of actual shade. And anything past the zero to the right stays in the shade at low tide. And this is the mortality of sort of the large mussels that would produce the next generation in Stanley Park. And you can see that most of the ones that were in the sun had extremely high mortality, 90 to 100%. And it was only to when you got to sort of right at the edge of shade were things safe. And then the animals that were in the shade at low tide were actually fine. So we've got big scale patterns of mortality, these sort of fine scale patterns as well. And then there's also some really interesting differences between species. So our native mussels, lots of mortality. Our native barnacles, lots of mortality. All of these species did pretty well, and they are all introduced mostly from East Asia, and East Asia is just naturally warmer in the summertime. So the Japanese seagrass was fine. These little anemones were actually more abundant after the heat dome than before. This is the Pacific oyster. There was some mortality there, but not nearly as bad. Mud snails, varnish clams, a few sponges, limpets. So I think that as we have more of these events, our ecosystem is going to shift from things that we've had around for millennia towards these newly introduced species that are just naturally more tolerant of high temperatures based on where they grew up, so to speak, where they evolved as a species. And you could see this at individual places. So this is a rock close to where I live in Kitsilano, where the introduced oysters were fine. These little barnacles are empty because they've died. And then the mussel shells down here are also the evidence that the mussels used to live on this rock and they also died. So we're seeing this shift. Okay, so to not depress you completely start to finish, there have been some signs of recovery. This is the Boulder Field. For those of you who are familiar with Vancouver, this is at the north end of Kits Beach with downtown Vancouver in the background. And the photo shown here is all of the seaweed that normally lives on that shore. This was taken just after the heat wave had happened. So the seaweed has actually been killed, but it hasn't washed away yet. 10 days later, you can see evidence of it washing away. And by the spring of 2022, this area and lots of other places around the lower mainland looked just awful, really scorched. But by summer of this year, the seaweed's on the way back. The barnacles are doing really, really well. The mussels are starting to come back too. So these systems are resilient. And I want to end on this note of this seaweed, the rockweed, because this is a cold, wet blanket that helps protect other things during heat waves. So one last quick video taken in Howe Sound right after the heat dome in 2021. You can see all the dead mussels there. But if you move the seaweed out of the way, that's where the survivors are. So that's, the parents of the next generation come there. So I want to put in a strong plug for trying to conserve our ecosystems, because having species like this rockweed helps protect other things. The mussels protect other things. Even the snails help protect other things. So that's my note of optimism is, we can't fight global warming and fix it in the next 5 years, but we can help sort of protect our local shoreline ecosystems, and that has a benefit too. So I will leave it there and take any questions that people might have.